In this video, we're going to learn about the focus directrix property of a parabola. So here's how we define a parabola using the focus directrix property. A parabola is a set of points which are the same distance from another point called the focus and a line called the Directrix. So why don't we go ahead and illustrate this for a particular case of a focus and a directrix. Why don't we say that the focus is the point 0, 1. So we'll draw that focus right over here, 0, 1. And why don't we say the directrix is the line y equals -1. So we'll draw that line, y equals -1. That's right over here. Now let's draw the parabola which corresponds to that focus and that directrix. Alright, so parabola is the set of points which are the same distance from the focus and the directrix. The first point that jumps out to us is just halfway in between the focus and directrix, right there at the origin. That's a distance of 1 unit from the focus and 1 unit from the directrix. And then, okay, what's the next point? Hey, over here, the point 2, 1. That's 2 units from the focus and 2 units from the directrix. And there's also another point up here. This one's a little bit less obvious, but the distance from the focus, well, it goes up 3 units over 4 units. So using the Pythagorean theorem, that has to be part of a 3, 4, 5 triangle. So the hypotenuse has length 5. So 5 is the distance from the focus to this point. And 5 is also the distance from this point to the directrix. We can also mirror these points on the other side. So right over here and right over there. And we really see that parabola shape happening now. Let's go ahead and trace that in. So the parabola looks something like this. Okay, so that's the graph of this parabola. And what if we wanted to find the equation of this parabola? What is the equation of this parabola? Let's try to derive it from scratch. Of course, we know it's going to take the form y equals something times x squared, but let's see if we can actually get that based only on this focus directrix property. So here's how we'll start it off. We'll say that given a point x, y, we must have the following equation. We must have that the distance from focus is equal to the distance from directrix. So now let's get an expression for the distance from the focus and the distance from the directrix, and we can look at our diagram to help us. So we're given a point x, y, and that point is going to be somewhere on the parabola. Why don't we say it's over here? This point, we'll just call this point x, y. Now to get the distance from the focus is 0, 1, we can just use the distance formula to find the length of this segment connecting this point x, y and the focus. So using our distance formula, we can write that down. The distance formula says that the distance there is the difference of x coordinates squared. So x minus 0 squared, and then plus y minus 1 squared. And now that has to be equal to the distance from the directrix. And what is the distance from the directrix? It's just the vertical distance down to the directrix line there. We can break this up into two portions. First of all, there's the portion from the x-axis up to the point, and that has distance just y, of course, that's just the height of the point. And then this other portion from the x-axis down to the directrix, that's just 1 unit. So the total distance there is just y plus 1. Add those two segments together. So distance is y plus 1. And now it just remains to simplify this equation. Let's go ahead and do that. So first of all, let's simplify inside of the square root here. X minus 0 is just x, and x squared, we can just write that as x squared. So x squared plus y minus 1 squared is equal to y plus 1. And then we can get rid of the square root by squaring both sides of this equation. So x squared plus y minus 1 squared is equal to y plus 1 squared. Let's go ahead and expand out these squares, and I bet some stuff will cancel. We'll have x squared, then plus y minus 1 squared, that comes out to y squared minus 2y plus 1. And then y plus 1 squared becomes y squared plus 2y plus 1. And we see immediately that we've got y squareds on both sides of the equation, so we can subtract those out, cancel those out. Same with the 1s on both sides of the equation, cancel out those plus 1s. So let's collect all that up again. So we've got an x squared on the side, x squared minus 2y is equal to 2y. We're almost done, but we're running out of room, so let's move it up over here to continue our solving. So we've got x squared minus 2y equals 2y at this point. And we can go ahead and add 2y to both sides of the equation to cancel out this minus 2y on the left-hand side. We'll just get x squared is equal to 4y. And then divide both sides by 4 to get that 4 off of the y. Get 1/4 x squared equals y. Just for aesthetic reasons, let's flip that around. Y equals 1/4 x squared. So there we go. There is the equation of this parabola. And that makes sense with what we already know is going to be something times x squared. But the cool thing is we were able to get that formula just from the focus directrix property of the parabola. That's pretty neat. Next problem, we want to find the equation of the parabola whose focus is at the point 5, 0 and whose directrix is the line x equals 1. Okay, so why don't we go ahead and plot this first like we did previously. We'll go ahead and plot the focus that's at the point 5, 0. So count 1, 2, 3, 4, 5. There's our focus right over there. And how about our directrix? Directrix is just the line x equals 1. So let's go ahead and draw that. X equals 1. That's just a vertical line passing through that x-intercept of 1. And maybe we can plot a few points on the parabola as well. First of all, easy point, right smack in the middle between the focus and the directrix. And then, let's see, this distance, this full distance is 4. So what if we go 4 up also? 1, 2, 3, 4. That way, the vertical distance from the focus is 4, and the horizontal distance from the directrix is also 4. We can mirror that on the other side also. 1, 2, 3, 4 over there. And why don't we go ahead and connect it up? This gives us a pretty good shape of what our parabola is looking like. Cool. Okay, so we've got a rough sketch of it. But the big thing again is we want to get the equation of the parabola. And we'd like to do that using the focus directrix property. So again, we'll just go ahead and start with that focus directrix property. That just says that given a point x, y on the parabola, the distance from the focus has to be equal to the distance from the directrix. So why don't we go ahead and draw our point, call it just call it xy on the parabola, any point. And let's first compute the distance from the focus. The focus is 5, 0. So the distance from the focus here we'll get by just applying the distance formula. And the distance formula is just the square root of the difference in x coordinates squared, so x minus 5 squared, and then plus the difference in y coordinates squared, so y minus 0 squared. And that has to be equal to the distance from the directrix. Let's see what the distance from the directrix is. We want to calculate this distance here from the directrix line all the way to that point. And how do we get this distance for any point x, y? Well, we know that the distance from the y-axis would just be the x-coordinate. The distance from all the way from over here to over here would be the x-coordinate. But that distance is a little bit too much. It includes this distance right over here, which is 1. And we don't want to include that distance. We only want the part that's to the right of 1, because the directrix is at x equals 1. Otherwise, it would extend beyond the directrix. That would be no good. So if this whole distance from the y-axis is x, and we don't want to include this distance of 1, what's the remaining distance? Well, just subtract off that distance of 1 from x. So we get x minus 1 is the distance. So distance from directrix is x minus 1, and now we've got our equation, and we can simplify it. So let's go ahead and do that. First, simplify the square root. So x minus 5 squared, and then y minus 0 is just, well, y, and y squared is just y squared. All right, so that's equal to x minus 1. Now let's get rid of that square root. So square both sides, and we just get x minus 5 squared plus y squared is equal to x minus 1 squared. And we can expand out these squares. I bet some stuff will cancel. Expand out this square first. We get x squared minus 10x plus 25, and then plus our y squared. That's equal to x squared minus 2x plus 1. And immediately we see x squareds on both sides of the equation, so cancel those, subtract those off. And let's get all of our x on a single side of the equation. We'll have that x is some function of y squared. So why don't we move all the x's to the right-hand side, because we've already got y squared on the left-hand side. So I want to do a plus 10x on both sides, plus 10x, and get rid of this constant, so minus 1, minus 1. And what's the result of that? Well, minus 10x plus 10x, that cancels. 25 minus 1 is 24. Then we've got our plus y squared equals 10x minus 2x is 8x, and then plus 1 minus 1, those cancel. All right, so divide both sides by 8, and we get that 24 divided by 8, which is 3, then plus an eighth of y squared is equal to x. And just flip that around so it's nice to look at. X equals 1/8 y squared plus 3. There's our equation. And just as a sanity check, this makes sense because the leading coefficient is positive, so it's opening in the positive x direction. Yep, that matches up. And it hits the x-axis at 3. Yeah, right there. So now we know the focus directrix property of a parabola, and we know how to use it to find the equation of a parabola. Now in all these problems, we were given the focus and the directrix, but in the future we'll also practice solving for the focus and directrix when we're given the graph of the parabola.